Okay, so in the previous video, we had seen how to take a problem that's in the standard form right here and then transform the problem by the addition of slack variables into a new form which does not change the meaning of the problem, but by adding the slack variables, it does change the structure of the problem. And then we organize the problem into this data structure called the dictionary, which has basic variables, in this case x4, x5, and x6. On the right, you show a generic dictionary with xb as the basic variables, and non-basic variables or independent variables. In the left-hand side example, that's x1, x2, x3. The right-hand side, that's xi. Okay, so we are now going to move forward and explore the dictionary in more detail so that we can understand the simplex algorithm. And one of the interesting things to explore is the solution that's associated with the dictionary coming right up, and then the notion of feasibility and infeasibility for dictionaries. So we'll talk about these two coming right up.
Okay, so one more concept is that every dictionary has a solution associated with it. Okay, and the solution associated with this dictionary is x1 equals 0, x2 equals 0, x3 equals 0. So first of all, rule is every non-basic variable is automatically set to a 0. That's a rule. Okay, rule number 1. Okay, every non-basic variable automatically has the value 0. And all basic variables you have to read off from the dictionary. So if x1 is 0, x2 is 0, x3 is 0, x4 is 5 minus 0, minus 0, minus 0. So x4 is 5. Okay, x5 is 11, and x6 is 8. So let me recall and write down the solution. The solution is x1 equals 0, x2 equals 0, x3 equals 0. This is the no-brainer part because these are non-basic. Okay, so this is the no-brainer. And x4 equals 5, x5 equals 11, x6 equals 8. So this is for the basic part. And once you set the non-basic variables, the basic variables take on values according to this dictionary. Okay, so and if you set all non-basic variables to 0, which is the rule, then the values of the basic variables can be read from here. Okay, and one more thing is the value of z. So z's value is simply going to be obtained by plugging in x1 equals 0, x2 equals 0, x3 equals 0. So this whole thing becomes 0, and therefore z's value in this dictionary is 0. So x1 0, x2 0, x3 0, x4 5, x5 11, x6 8, and z 0. That is called the solution that's associated with this dictionary. So with every dictionary comes along the solution, and here it is. All right. Next step, let's look at another dictionary. So this is another dictionary. It's actually a dictionary for the same problem, but I will not go over that right now. So let's just imagine that this is another dictionary I came up with. In this dictionary, the basic variables are x4, x2, and x6. So these three together are the basic variables. The non-basic variables are x1, x5, and x3. Can you take a minute and write down the solution associated with this dictionary? Let's do this at the same time. Okay, simply x1 is 0, x5 is 0, x3 is 0, because every non-basic variable automatically is zeroed out. What about x4? Okay, so x4 is minus 28. Okay, these are not minus signs, these are just arrows. X2 is 11, and x6 is minus 32. Okay, how do I read that off? x1 is 0, x5 is 0, x3 is 0, so this whole thing is a 0. Okay, therefore, only thing left over is minus 28. So x4 is minus 28. x2 is 11, and x6 is minus 32. Okay, so some of you may have remembered and I'm guessing some of you may have already forgotten, that there are these unspoken constraints, x1 greater than equal to 0, x5 greater than equal to 0, x3 greater than equal to 0, x4 greater than equal to 0, x2 greater than equal to 0, and x6 greater than equal to 0. And these are constraints that are unspoken. They are there, but we are not writing them down. Okay? Now, you may look at this dictionary and say, well, x4 equals minus 28 violates one of those unspoken constraints. How can x4 be greater than equal to 0 and have a solution of minus 28? Okay? So there is something wrong with this dictionary. Okay? So therefore, we call dictionaries which respect the feasibility constraints x greater than equal to 0 as feasible dictionaries. Okay? And dictionaries which do not respect these constraints, like if they have a negative entry here, we call them infeasible. Okay? And by the way, in this dictionary, the objective function z has value 44, but the dictionary is infeasible. In this dictionary, the objective function has a value 0, and the dictionary is feasible. Okay? So, to recap, every dictionary has a solution, and looking at the dictionary, you can read the solution off automatically. It's very important to understand these concepts. And furthermore, it's important to understand there are feasible dictionaries and there are infeasible dictionaries. Feasible dictionaries respect these constraints, x greater than equal to 0, and infeasible dictionaries, well, they don't. They don't respect constraints. Okay, so you may be wondering, why dictionaries? Why are we worrying about dictionaries? Well, as a computer scientist, I need a data structure. I need to code this up. I'm going to quickly tire of actually doing this by hand. And if I need to code this up, I need good data structures. And dictionary is a great data structure for storing information about a linear program. And we will show how to data structure these things very efficiently as we go along. The other thing is a dictionary represents a candidate solution to a problem. And the one thing that I did not say on this slide is it makes reasoning about linear programs very easy and very simple, and we will see how that works out. Okay? So we are now ready to look at the simplex algorithm from 2000 feet. Okay, so this is a 2000 feet description of a simplex algorithm. So what the simplex algorithm is going to do is, from the problem you're given, it's going to get to the first dictionary. Okay? And sometimes the first dictionary may be feasible, sometimes it may be infeasible. So if these are first dictionaries infeasible, we are going to do this magic operation called pivot, 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 pivot until we get to a feasible dictionary. And the way we do this is going to be called the initialization phase simplex. Okay, some people will call it phase 1 simplex. This is called initialization phase simplex. And once you land to a feasible dictionary, your first feasible dictionary, you then start a new kind of simplex called the optimization phase simplex, and you go pivot, 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 this magic operation called pivot, which I haven't told you about yet, okay, and it's going to be the real magic, and you finally get a dictionary D star, which is going to be final, and you read off the answer from this final dictionary. So this is going to be the structure of the simplex algorithm. You start with some infeasible dictionaries, and we are going to do some magic there to get to a feasible dictionary. Okay, so this picture here is not quite correct, but it's accurate enough for now. From 2000 feet, you can't make out these details unless you are an eagle. Okay, once you land to a feasible dictionary, you keep pivoting. You will maintain feasibility until you get to an optimal solution. That's how simplex is going to work, and this picture we'll keep in mind as we work through the minute details of simplex, but this is the big picture I would like you to keep in mind. Okay? Alright, so we are almost done with this segment. Okay, this act is almost coming to an end. So let me summarize. Summary, number 1, we transformed the problem to add these slack variables. We took the standard form, we added the slack variable. Summary number 1. Summary number 2, we converted after the slack variable to this structure called the dictionary. Okay? And the dictionary is a structure for representing the problem. These are called non-basic. These are called basic. Okay? Alright? And every dictionary has a solution associated with it. You read off that solution by setting all non-basic to 0. which means you can ignore this part of the dictionary entirely and read off the solution for the basic and the objective by looking at this row or this column. Okay. Finally, we have the notion of feasible versus infeasible dictionaries. Feasible dictionaries means that all these guys are going to be greater than or equal to 0. Okay, so there is no constraint on the objective. Okay, everything else, the B vector is going to be greater than or equal to 0. That means feasible. Infeasible means one of these solutions is less than 0. And the way we understand it is this constraint, x greater than or equal to 0, which is not written down, is violated by the solution, then you call it infeasible. If it is satisfied, you call it feasible. So that concludes my summary, and that concludes the second act. The third act, we are going to look at this magic called pivoting. So pivoting is going to be the key magic that drives the simplex algorithm, and the properties of the simplex algorithm are going to come forth from the way we will pivot. So this is going to be the third act of our lecture, and we'll get to this in our next video.